today's problems, we're going to be going through the practice problems for Unit 2, Lesson 11, and we're going to be looking at interpreting graphs of those proportional relationships that we've been working on. So here's a proportional relationship between the number of months a person had a streaming movie subscription. I know a lot of us have those. And the total amount of money they paid for that subscription. The cost for 6 months is $47.94, which they've shown us right here as the coordinates, and there, of course, is the point. So that point is shown on the graph below. The first thing they ask us is the constant of proportionality in this relationship. So we know that when we find the constant of proportionality, it's always y divided by x. So y, you should know, is on this up and down, the vertical axis. And in this case, y, if we go up to here and look across, and it's told us the coordinates, 47.94. We know that's $47.94. And we would be dividing that by what x is, and in this case that's 6. Go ahead and use those calculators, and you should find out that y divided by x is $7.99, or $7.99. So the constant in this relationship, constant of proportionality, is $7.99. The next thing they're asked is, what does it tell us about this situation? Well, I know I used the room down here, so I'm just going to write it up here. That tells us that 1 month of the movie subscription is equal to $7.99. The next thing it asks you to do is to add at least 3 more points to the graph and label them with their coordinates. So this is simple enough. You really can set up a table and just put in as many points as you'd like. So our table, I know that we probably want to start with time. That's our x, or t. Remember, this is the x-axis. Up top is the y. So in this case, I'm just going to go, like they've already given us the 6, so I already know that 1 time and then the cost, so we'll make that c. I already know that 1 is $7.99 because that's my constant of proportionality. Remember, in this case, t divided by c. Oh, sorry. Because I wasn't using x and y, I got myself a little confused, which is common. Of course, that's y divided by x, which in this case is c divided by t. Because, of course, $7.99 divided by 1 is $7.99. So if I just go right along, 2 times $7.99, of course, is $15.98. And I could go right up to that 10. 10 times $7.99 would be $79.90. So I know I've got my 1. It's kind of difficult using this stylus on here, but it would be about there. I know that that's a line, not really a point. 2 would give us about here. 10, we know, can be far more accurate. It should be about there. Now, it doesn't tell us to put a line, but you should be noticing that they are in a straight line, and of course they start at 0 because 0 months is going to cost $0. And then it tells us to write an equation for the relationship. Oh, they gave us the c and the m. I apologize. So this t should have been m, and this could have been m here. So anyway, regardless, c, we know that the cost, how did we go about finding that? Well, we took m, number of months, and what did we do with it? Well, we multiplied it by $7.99 times $7.99, and that got us c. Now, of course, the correct way to write that, which is why I started it this way, would be c is equal to 799 m. Remember, only the variable next to the number. We don't need anything in between those two to represent multiplication. Next problem. This graph shows the amounts of almonds in grams for different amounts of oats in cups in a granola mix. So label the point 1K on this graph and then find that value of K. So basically it's asking us to start with the 1 and go up the line and see where it crosses, like where we get to the line. It's right there on that spot. And it does look like if I look straight across, it appears to be right at 25. But the way that I would go about checking that would be to go to 2 and see that it's an exact point right there. That point is 250. So that tells me for sure that this point is 125, and that therefore K is equal to 25. And the meaning of K is telling us that there are 25 grams of almonds, and remember we can look at that right on our label here, which one of the reasons it's so important to make sure you label your graphs. 25 grams of almonds for 1 cup of oats. And the last problem that we had to do, we're making a friendship bracelet. We've got a number of long strings, which are lined up. So if I wanted to imagine it, here's my long strings. Doesn't matter how many there are. Take one string and tie it in a knot with each of the other strings. So 1 will go to 2, 3, and 4. And then a new string is chosen to go between the others. 2 would then go to 1, 3, and 4. 3 would go to 2, 1, and 4. And 4 would go to 3, 2, 1. This process is repeated until there's enough rows to make a bracelet to fit around your wrist or your friend's wrist. And it asks you, are the number of knots proportional to the number of rows? Number of knots proportional to the number of rows. And the answer to that, like if I look at this, how many knots are in this one? There's 1, 2, 3. The next one has 1, 2, 3. Next one is 1, 2, 3. 1, 2, 3. So there's 3 knots in each one. 3 knots in each one. So in this particular case, we're using a diagram to figure it out. So the answer is yes. It is proportional. And the reason it's proportional is because each row has the same number of knots. So no matter how many rows there are, it will always be equal to the original 3 over 1. And just to make that even clearer, at the end of the first row, 1 times 3 is 6. At the end of the second row, 2 times... Sorry about that. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. You can see how they go up proportionally. And every one of those, if I were to reduce them, would give me back that 3. So the answer again is yes, and that's because it increases by the same number each and every time, which again would be our constant of proportionality.